Okay, problem 6, first part A. The curve is x equals y minus y squared. Okay, so y is 0, x is 0, y is 1, x is 0, and it's a quadratic equation, right? So the curve looks like this. And now you revolve the region bounded by this curve. Right? This curve is this. And x equals 0 about the y-axis. So you are revolving this two-dimensional piece, right, around the y-axis. So revolving it around the y-axis. You can just imagine this on your head. It will be a three-dimensional object, right? It should be a shape of like American football. Okay, so again, the same idea. We have to find the area of each cross section. So for area of each cross section, for example, if y is given, right? If y is given, then this part is what? It's just y minus y squared, right? It's y minus y squared, and you revolve this blue line 360 around the y-axis, you should get a circle, right? You should get a circle. So it is pi r squared. So this part is the radius of the cross-section circle. Right? So you pi r squared. This part is what? This part is the area of cross-section area. Okay, and you integrate the cross-section area for y from 0 to 1, right? So this part is the volume of the object. Okay, then you do the calculation. It's pi over 30. Right. Part B. Part B, find the volume. So first, y equals x cubed looks like something. And lines y equals 0. So y equals 0 is this line, right? And x equals 2. So x equals 2. This should be 8. Right? So it's this part. It's revolving about the x-axis. Right? So again, for a line, right, for each x, if x is given, then this line, blue line, you revolve it 360 about the x-axis, you should get a circle, right? You should get a circle. So if x is given, then what is the radius of this circle? The radius of this circle is x cubed, right? This is the radius of the circle, cross-section circle. And then you pi r square, right? This part is cross-section area, and you integrate it from 0 to 2, right? Because these two are your boundaries. This will be your volume. Okay, this will be your volume. Part C. So now you have a curve y equals x and y equals square root of x. Okay, square root of x is something like this. When x is 1, right, this part is y equals square root of x. So this is a region bounded by these two curves. You revolve it about the line x equals 2. Okay. So revolve it about the line x equals 2. So as you can imagine, if each y is given, right, if each y is given, we revolve it around x equals 2. Okay, so what should you get? The cross section it should look like a circle, a larger circle, and a smaller circle. Right, and this is a cross section area. Right, and this is the radius. Let's say this is a radius, let's say R2. Then on the graph, this is the radius R2. Right, and this is the radius R1. And on the cross-section graph, this is R1. Right, this part is R1. So the cross-section area, it's what? The cross-section area is pi R1 square minus pi R2 square. Okay. Then for each, so now, for each y, right? For each y, what is your R1? Right. So if y is given here, if y is given, let's say if y is given, then this part is what? This part is x equals y square, right? This part is x equals y square. So, and we know overall this part is 2, right? This total length is 2. So this part is y square, this part is R1. R1 plus y square is 2. So R1 is 2 minus y square. Okay, what about R2? R2 is just 2 minus this part. What is this part? How long is this? Okay, y is given, this part is x, right? Because this point is along y equals x. So R2 is 2 minus x, and x equals y. Right here, x equals y, so it's 2 minus y. Right. So the cross-section area is, right, the cross-section area it is pi R1 square minus pi R2 square. Okay. So the volume is the integration of, so now y is from 0 to 1. Okay. Y is from 0 to 1. After that, it's just a calculation. It is 8/15 pi. Okay.